On paper, this ship was built for one purpose: to put armored vehicles and Marines onto contested beaches. Helicopters on the flight deck, hovercraft in the well deck, missiles and close-in guns guarding the perimeter. A flagship for expeditionary war. Then a single construction spark found oxygen. Within minutes, black smoke towered over the yard. Flames climbed elevator trunks and raced through unfinished compartments. Fire boundaries were not sealed. Hatches stood open. Electrical trunks were exposed. The contradiction was immediate. A vessel designed to survive missile strikes struggled to survive a welding arc. And that raises a deeper question, not about this one ship, but about survivability culture. Because in naval warfare, weapons matter, but damage control doctrine decides who stays afloat. The United States Navy learned that lesson in blood, from the USS Forrestal to the USS Stark, from combat hits to shipyard accidents. Material conditions Zebra exists for a reason. Compartmentalization is not cosmetic, it is geometry. China's new amphibious assault ship would later be repaired, commissioned, and renamed. But what burned in Shanghai was not just insulation and paint. It exposed something more fundamental. And here is the open loop that matters. When a warship catches fire in combat, steel does not burn. Systems fail. Boundaries matter. Response discipline decides survival. If those habits are not embedded during construction, can they suddenly appear under missile attack? We will come back to that geometry of survivability. Because this story is not about mocking an accident. Accidents happen in every navy. The United States lost USS Bonhomme Richard to a catastrophic pier-side fire during maintenance. Fires in shipyards are real. They are dangerous. They test doctrine. This is about something more structural, image versus resilience, and whether speed of construction can outpace the physics of fire at sea. The vessel at the center of this incident would later enter service as CNS Hainan, the first of the Type 075 amphibious assault ships. CNS Hainan. At roughly 40,000 tons full load, the Type 075 places China in the same weight class as modern Western amphibious assault ships such as the USS America. USS America. This is not a coastal patrol craft. This is an expeditionary platform. The design centers around three geometries. A full-length flight deck capable of operating multiple medium-lift helicopters simultaneously. A floodable well deck designed to launch Type 726 air cushion landing craft. Internal vehicle and troop spaces configured for battalion-scale assault waves. In doctrine, that translates to vertical envelopment and surface assault combined. Helicopters establish air superiority over the beachhead. Hovercraft deliver armored vehicles and logistics. Missile escorts screen against surface threats. In a Taiwan contingency, such a platform becomes a spearhead. And that is why symbolism matters. The Type 075 is not just another hull number. It represents a shift from coastal defense toward expeditionary capability. It signals an ambition to project force across the Taiwan Strait and beyond. Numbers amplify that signal. China has expanded its navy to over 350 hulls. Amphibious brigades have grown. Marine Corps personnel have increased. Landing capacity has multiplied. On paper, the equation appears straightforward. More hulls, more lift capacity, more mass at the shoreline. And mass matters in amphibious warfare. But amphibious assault ships are not artillery barges. They are floating airfields and troop carriers, dense with aviation fuel, wiring, munitions handling spaces, and vertical elevators. Our trunks. That density creates vulnerability. Fire spreads through ventilation trunks. Smoke rises through open shafts. Electrical failures cascade, which is why navies obsess over material condition states. Material condition Zebra in the US Navy means every watertight door, hatch, and ventilation closure is sealed to maximum survivability posture. Even in port, even during drills. It is not about paranoia, it is about geometry of containment. A ship is a floating steel box subdivided into smaller boxes. If those boxes are sealed, fire remains local. If they are open, fire becomes systemic. During construction, however, those boxes are not yet complete. Compressed air lines snake through compartments. Temporary electrical runs bypass finished conduits. Fire retardant coatings may not be fully applied. This is where schedule pressure meets physics. China's shipbuilding industry has moved at extraordinary speed over the past decade. Multiple destroyers launched per year. Amphibious hulls constructed in parallel. Carrier development accelerating. Speed generates headlines. But survivability culture does not accelerate on command. It is procedural. It is drilled. It is enforced. And that tension between rapid fleet expansion and ingrained damage control discipline sets the stage for what happened in April 2020. Because when sparks fly inside an unfinished hull, what protects the ship is not its missile battery. It is the culture of the yard. And that is where the real test began. Before the fire, the narrative around the Type 075 was simple. Scale equals leverage. At 40,000 tons, the platform could embark roughly 30 helicopters depending on mix, carry hundreds of Marines, and deploy multiple air cushion landing craft from its well deck. In amphibious warfare, lift capacity is geometry. The wider the assault front, the harder it is to contain. Add escort destroyers with long-range surface-to-air missiles. Add shore-based ballistic missiles covering the strait. Add land-based fighters operating from interior airfields. Layered denial. From Beijing's perspective, the Type 075 was not operating alone. It was one node inside an anti-access network stretching from the mainland coast outward. Numbers reinforced the confidence. 3 Type 075 hulls under construction nearly simultaneously. Parallel expansion of landing ship docks. Expansion of the Marine Corps. Mass production creates strategic pressure. If one amphibious ship can land a battalion, 3 can open multiple axes. If escorts provide overlapping radar coverage, inbound aircraft must penetrate concentric rings of sensors. The math appears intimidating. This is where many observers stop. They see tonnage and assume inevitability. They see new hulls sliding down slipways and assume survivability comes, packaged with steel. But amphibious assault ships are among the most vulnerable major combatants in naval warfare. They carry aviation fuel. They carry ordnance. They carry hundreds of personnel concentrated in tight compartments. They are not armored battleships. They are mobile logistics hubs. And survivability depends less on thickness of steel than on internal discipline. The April 2020 fire began during fitting out. Welding work, sparks, combustible materials nearby. During construction, doors are often left open to route temporary power lines and ventilation. That is normal in shipbuilding worldwide. Fires during yard periods are not unique to any country. The United States experienced catastrophic loss with the USS Bonhomme Richard during maintenance. USS Bonhomme Richard. Accidents happen, but what determines scale is response speed and boundary control. In Shanghai, flames reportedly spread through the well deck area and up elevator trunks. Thick smoke poured from the hull, visible across the yard. Compartments were unfinished. Fire suppression systems may not have been fully operational. The key word is containment. If boundaries are incomplete and fire watch discipline is inconsistent, small ignition points become structural events. This is where survivability culture is either proven or exposed. Because a warship's first battle is not against an enemy missile, it is against entropy, Duri, Ning construction. If you were planning amphibious operations, would you prioritize rapid hull expansion or slower builds with obsessive damage control redundancy? Which variable wins wars, volume or resilience? Your assessment. The contrast often cited by experienced sailors is not about perfection, it is about doctrine. In U.S. naval culture, damage control is not an auxiliary specialty, it is universal. Every sailor trains for it. Every compartment has assigned boundaries. Every hot work evolution requires a fire watch, and that watch remains in place until metal cools. Material condition states exist even pier side. Zebra means maximum closure. Yoke and X-ray define intermediate readiness. These are not bureaucratic labels. They are survivability geometry. A modern amphibious assault ship like the USS America is designed with layered fire mains, automatic sprinklers, halon or aqueous film-forming foam systems in critical spaces, and distributed damage control lockers. USS America Fire Control is a system. Detection sensors identify heat rise. Alarms activate across compartments. Fire parties respond with breathing apparatus and pre-assigned hose routes. Boundaries are set immediately to isolate airflow. The objective is not heroics, it is compartmentalization. Even during maintenance availabilities, U.S. doctrine mandates strict hot work permits, supervised fire watches, and layered authority between civilian yard workers and ship's crew. When that coordination fails, as seen in San Diego, consequences are severe. The loss of USS Bonhomme Richard demonstrated that accidents are not exclusive to any navy. USS Bonhomme Richard. The difference lies in institutional response and procedural reinforcement afterward. Innovation in survivability is often invisible. It does not photograph well. It does not headline well. But it is engineered. Redundant pumps, independent power loops, separated cable runs to prevent single-point electrical cascade. These are design choices born from decades of combat damage analysis. This is not about claiming immunity. No navy is immune from human error. It is about institutionalizing correction. Because an amphibious assault ship is not simply a weapons platform. It is an integrated system where aviation operations, well-deck flooding cycles, fuel transfer, and command networks intersect. If one fire disables electrical trunks running vertically through the ship, Elevators stall. Ventilation stops. Sensors fail. The question is whether internal architecture anticipates that cascade, and whether the culture operating the ship drills for it relentlessly. The reassurance is this: survivability is not a bolt-on feature. It is embedded in doctrine, training cycles, and inspection regimes long before deployment. But the escalation is coming, because once the Type 075 returned to service cosmetically repaired, the deeper issue was not charred paint. It was whether foundational habits had been stress tested or merely patched. Fire at sea is not cinematic. It is mathematical. Inside a steel hull, heat rises at roughly 3 to 5 meters per second through vertical trunks. Smoke spreads laterally through open passageways. Electrical cabling acts as both fuel path and signal artery. If boundaries are sealed, the fire is boxed. If boundaries are open, the fire becomes geometric expansion. During the April 2020 incident, visible smoke columns indicated rapid vertical spread. Elevator trunks are natural chimneys. Unsealed compartments allow oxygen feed. This is not about whether steel burns. Steel loses structural strength at approximately 600 degrees Celsius. At 1,100 degrees Celsius, it can lose over half its yield strength. That does not require total melt. It requires heat concentration. An amphibious assault ship's well deck contains fuel lines, hydraulic systems, and vehicle staging areas. During construction, temporary cabling and insulation materials increase combustible load. The ignition source may have been minor. The propagation was not. Now shift from dockside to combat geometry. Imagine the same vessel under missile threat in the Taiwan Strait. A sea-skimming anti-ship missile detonates near the waterline. Even if the hull is not penetrated catastrophically, spall and overpressure can ignite secondary fires in aviation fuel lines or vehicle decks. Survivability becomes a race between suppression rate and spread rate. Suppression rate depends on trained fire parties, immediate boundary setting, operational sprinklers and foam systems, redundant fire mains with pressure maintained. Spread rate depends on open compartments, ventilation flow, vertical shafts, combustible density. The equation is simple. If spread rate exceeds suppression rate, the ship is mission killed. That is not speculation. That is naval history. Some viewers argue accidents happen everywhere, and they are correct. The United States lost USS Bonhomme Richard to a catastrophic pier-side fire. USS Bonhomme Richard. But post-incident analysis revealed breakdowns in watchstanding discipline, alarm escalation, and command coordination. That loss triggered institutional review, legal proceedings, and doctrinal tightening. Operational maturity is not the absence of failure. It is the correction mechanism afterward. Now apply cost logic. A Type 075 amphibious assault ship is estimated in the hundreds of millions of dollars. It carries hundreds of personnel and aviation assets worth additional billions. One anti-ship missile costs a fraction of that platform. Cost per kill asymmetry is brutal in naval warfare, which is why survivability culture must be overbuilt. Because if a ship cannot contain a welding spark efficiently during construction, adversaries will calculate what happens under precision-guided munitions. This is not about mockery. It is about deterrence math. Would you risk concentrated troop lift on a platform whose damage control systems have not been stress-tested under combat simulation? Or would you distribute assault waves across multiple smaller vessels to reduce single-point failure risk? Your operational calculus. Here is the deeper pivot. The Type 075 returned to service. Cosmetic repairs completed. Commissioned as CNS Hainan. CNS Hainan. From satellite imagery, the deck looks clean. But survivability is not paint deep. Fire control systems require drilling. Boundary discipline requires repetition. Command authority must be unambiguous during crisis. If confusion exists between civilian yard management and naval command during construction, what happens when electronic warfare disrupts communications during combat? This is where systems integration becomes decisive. In U.S. doctrine, amphibious assault ships do not operate alone. They are screened by destroyers providing layered air defense. Aegis radar tracks inbound threats. Fire control solutions are shared across the network. Close-in weapon systems provide terminal defense. Layered defense reduces probability of hit. Damage control reduces consequence of hit. Both layers matter. The dominance is not in any single hull. It is in integration, sensor to shooter to suppression team, operating as one architecture. Numbers alone do not equal RE. Silence. Physics does not negotiate. After the fire, Chinese shipyards accelerated visible repairs. Insulation replaced, steel sections inspected. The ship eventually entered service. Additional Type 075 hulls followed. Expansion continued. From a strategic standpoint, Beijing did not pause amphibious development. It doubled down. But adversaries do not analyze only hull count. They analyze process culture. A rushed launch schedule, if accurate, signals industrial pressure. Pressure creates shortcuts. Shortcuts degrade redundancy. To be clear, shipyard fires are global phenomena. Welding in confined spaces is inherently risky. Combustible materials are common during construction. No navy is immune. The difference lies in institutional memory. When USS Bonhomme Richard burned, the U.S. Navy confronted public scrutiny, internal investigation, and doctrinal reform. USS Bonhomme Richard. Damage control authority lines were clarified. Training standards reinforced. Accountability pursued. Professional navies treat accidents as design feedback. Now consider the Taiwan scenario. Amphibious assault requires hours, sometimes days, of sustained exposure near contested coastlines. That exposure invites coastal anti-ship missiles, submarine torpedoes, sea mines, drone swarms, loitering munitions. This is not a video game. No amphibious platform is invulnerable. China understands this. It has invested heavily in shore-based missile coverage and fighter umbrella to suppress defenders before landing. That is logical doctrine. But once a ship closes inside missile engagement zones, internal survivability becomes the final line of defense. If damage control culture is rigorous, a ship absorbs damage and continues mission. If it is fragile, it becomes a floating casualty cluster. The open loop from earlier now resolves. Can survivability habits appear under fire if they were not deeply embedded during construction and training? History suggests no. Damage control discipline is learned through repetition before combat. It is not improvised during crisis. This is where the advantage shifts toward navies that institutionalized compartmentalization decades ago. Layered defense, redundant systems, continuous drills. Not glamorous, but decisive. The Type 075 did not sink. It was repaired, commissioned, and integrated into fleet exercises. China continues expanding its amphibious capability. Additional hulls entered service. Marine brigades train for over-the-shore operations. Helicopter decks cycle aircraft in coordinated drills. On the surface, the modernization drive remains intact. But legacy in naval warfare is not written by launch ceremonies. It is written by survivability under stress. Every navy that operates capital ships eventually faces fire. The difference between embarrassment and catastrophe is institutional depth. Damage control is culture. It is the sailor who automatically closes the hatch behind him. It is the officer who orders boundaries set without hesitation. It is the engineering officer who ensures redundant fire mains are pressure tested weekly. That culture does not emerge from propaganda timelines or accelerated yard schedules. It matures through decades of doctrine refinement, accident analysis, and relentless drills. The United States learned this through hard experience, from carrier deck fires in Vietnam to modern maintenance disasters. Each failure triggered review, procedural tightening, and design modification. No navy is immune to error, but only some build correction into the system. Amphibious assault in the Taiwan Strait would be one of the most complex joint operations of the modern era. It would involve missile suppression, air superiority contests, submarine screening, mine countermeasures, and sustained logistics over contested waters. In that environment, survivability is not optional. One compromised assault ship could strand hundreds of Marines and cripple operational tempo. Concentrated lift becomes concentrated vulnerability, which brings us back to the core contradiction. A 40,000-ton invasion platform can carry helicopters, missiles, and aircraft. But if foundational discipline in fire control and compartmentalization is inconsistent, advanced weaponry cannot compensate for structural weakness. Mass matters, but resilience determines endurance. Future naval warfare will not reward the side that builds fastest. It will reward the side that integrates sensors, shooters, and damage control into a seamless architecture, and drills that architecture until reaction is automatic. The math is unforgiving. Cost per kill asymmetry favors precision weapons. Missile ranges continue to expand. Drone saturation increases detection complexity. Survivability becomes the final multiplier. If you evaluate amphibious power strictly by hull count, you miss the deeper variable. Which navy has embedded resilience so deeply that even under missile strike, the ship fights the fire as aggressively as it fights the enemy? That is the real measure of invasion credibility. If you analyze naval power through systems integration rather than headlines, subscribe. This channel dissects warfare through physics and doctrine, not theatrics. In the next decade, the decisive edge will not belong to the loudest fleet. It will belong to the fleet whose ships remain operational after the first hit.